Thanks everyone for coming. I'd like to start with introducing myself. I'm Lisa Spelman. I'm the CEO here at Cornelis Networks. And I just want to tell you a little bit about us. We are a team of people, of engineers, of architects, of builders, of hardware, of software, people that are just maniacally focused on figuring out the fastest path for data. So while a whole bunch of the industry has been solving a lot of the compute scale out problems, and a lot of people have been working on algorithmic development and what's the next frontier model, what does that look like? Don't worry. We have been here all along solving all the ways that data can move and should move in the most efficient, scalable, and performant manner. And so we're here to talk to you a little bit about that today. I'm excited to share what we've been working on. So let's go ahead and jump in. Okay, so first we want to talk a little bit just about what is this hidden cost of AI. So much news and media and everything going on about how much will be spent in AI, whether that's actually from the hyperscalers, from the neoclouds that the last group was just talking about, enterprises around the globe. So, soup to nuts, there is now approaching $1 trillion of spend a year across infrastructure models, all of that investment, and it just keeps going up. There's a lot of conversation about how those dollars are being used and what they're being used for, but what they are resulting in is not a shortage of spending, but a shortage of utilization. So a lot of people don't have, that background and understanding. Obviously, many of you in the room do, of course, that there is so much of this CapEx and OpEx that is just getting burnt with underutilization. So in, training models, you see 39, 40, 42, 26% utilization rates. This example happens to be an NVIDIA one. In inferencing, this is a hyperscale example. You can get, or a training one as well, you can get 50% GPU utilization. And that's, if you think about, in this case, a hyperscaler being the most sophisticated, the most resource available enterprises in the world, and the most technical capability. And on their best day, they can get some of their models to 50% utilization. And so you go back to, where NVIDIA started in the morning talking about all of the capability and capacity and performance that they're putting into their GPUs and compute. And you sit there going, holy cow, 50% of that is going to sit on the shelf. So why is that? Well, there's more than one reason, but one of the reasons is because of the network bottleneck. So if you look at that, you see 32% of GPU hours are spent communicating, just having a nice little chat with each other. What are you up to? How about you? What are you up to? So that means your GPU is doing no math. It is just relaxing. It's burning power, but it is relaxing. And so that's not helping you advance your cause. That's not helping you build more efficient infrastructure. And it's not helping you get to your time to answer, your time to money, time to revenue faster. And then 30% about, of an epoch, so, one loop through the system, if you will, is spent recovering from errors. So the network is not the only bottleneck to this grand worldwide problem of AI inefficiency, but it is certainly a significant contributor. Okay. Why? There's so many smart people. There's wonderful companies. Ethernet's been around for a gazillion years. Like, how has this not been solved? I mean, we have bandwidth has just kept increasing. So fastest bandwidth speeds are available. You have both InfiniBand, you've got Rocky that are, very well established, very well developed, have tons of users and experience. They're delivering low latency. The hardware and software stack is tightly integrated. Some experience a maybe too tight integration, not giving them enough freedom of choice, but nonetheless, it's hard to argue work hasn't been done on the hardware software stack. The overhead of encryption and security. There was a few mentions of it throughout the day today, but it is yet to come. So the AI systems are not bearing that brunt or that burden of all of the data and the extra, communications and compute that will be required to deliver full, data at rest, data in flight, data in use protection. And then there's a lot of memory advancements, fastest memory, storage already in play. So why is the network still a bottleneck? So the way we like to think about it is that these are the glamour metrics. So these are the high-level glamour metrics, but it's what's under the hood that's holding everything back. So a less elegant term is the guts. The guts of the network are still suffering from disruptive congestion, from packet loss. So not every packet's making it, and then we're having to resend the packets and hope they make it again the next time. High tail latencies. Your last soldier is taking forever to arrive on the scene, the battlefield, as it were. You've got scale issues. We talk about, hey, we're going to get to these million GPU clusters, and there's a lot of work being done on that. You talk to any of the practitioners, whether they're hyperscale, neocloud, and enterprise, and over 1,000 GPU clusters, all hell breaks loose. So scale issues are still very real, even though many of them are being worked on fabulously hard right now. And then you have failure rates. We talked about that. Just too many failure rates inside both the GPU as well as inside the network as well. So at that top level, there's been tremendous advancements in the network and a lot of progress made, but in the guts, there is still real work to be done. And like I said, that's what our group's been working on. We've been spending, the better part of a decade perfecting and building an architecture and features that address this. So let's change these problems and let's go solve them for all of you. So like I said, we have an architecture at our company that we've built. It's called the Omni-Path architecture. And it is built to address these challenges within the network, paired with the best of all of the industry interoperability, as well as the accelerated bandwidth and those glamour metrics. So you have a series of features and capabilities, and this is just an example. Underneath these, there's many more that contribute to how you break through this networking bottleneck that is fundamentally holding back progress inside of the AI system. Okay, so let's talk a little bit about a few of these for a moment. So when you look at what are we trying to get to, we're trying to deliver an experience that is both lossless, again, that's no packet gets lost along the way, and congestion-free. So when you're lossless and you're keeping every packet in play, that is a wonderful environment to build up a ton of congestion. Think of it as your rush hour traffic. Every car gets launched to go home and none of them take an exit. You're going to end up with congestion. So how do you manage that? You use a series of capabilities and features. Like you look at credit-based flow control, which is essentially the way to ensure I only send what can be received. I'm only sending you if there's a parking spot where you need to go. And I can check that really efficiently, so much more efficiently than just sending you get there, no parking, and you go back home. You have things like enhanced congestion avoidance. So again, making sure that you don't end up in a cascading failure of events. So it's this pacing, getting ready, sending at the right pace for what the network can handle and what the GPUs accepting the data can handle. Last one here is on the fine-grained adaptive routing, which again gives you the capability to more intelligently choose your path. So you need to go from point A to point B, and there's a tremendous amount of congestion in the way. Well, the shortest distance might be a certain route, but the fastest distance is very different. And we want to allow for, in areas where there's going to be congestion, tons of data that happens, the ability to go around it and work around it and not get stuck. So this is, some examples of how the guts of the network and what's underneath your bandwidth really, really impact the performance. A couple more here in more of that reliability space is you look at dynamic lane scaling. So you have the opportunity to protect yourself, to protect your training run from a bad link. So you don't suffer when you have one of those failures that is incredibly common. Any of you that have worked in training environments with any type of scale know that you're somewhere in between 20 to 40 minutes or so before you end up with a failure and a need to checkpoint or go back to your last checkpoint. So if through this ability to keep the cluster up more, you have the ability to extend that checkpoint time even by 5 minutes and 10 minutes, right there, you're adding back a tremendous amount of efficiency every single cycle of the training run. And then you have the, link protection, again, error recovery, as well as avoiding those end-to-end retransmissions. No problem to send the data once. It costs you a lot when you have to send it again, and then try again anyways. Okay, so what does that lead to? It leads to an environment where you are getting greater performance and more capability out of your network investment. So you are investing in, hardware here, you're investing in your software, you're putting a lot of pressure on the network, and you fundamentally need more out of it. So how do you do this? That list of architectural elements leads to a situation of extremely low latency. So 35% lower latency in our network than you experience from other industry standard and deployed options out right now. You have the ability to scale at up to 500,000 endpoints. That's with our current generation and will continue to grow. So the ability to, across a cohesive network, scale up to massive type of endpoint clusters is incredibly valuable. And you get to faster collectives and better all reduce. So all of these are important in how you start to pull through performance, and you deliver that, again, faster time to money and faster time to result inside of this expensive infrastructure. So we here, we have this differentiated architecture, and it is also now being delivered through industry standards. So I shared with you all that we've been spending the better part of a decade developing that comprehensive, from the lowest level consideration all the way up to the system solution to solve these problems for both AI computing and high performance computing demands. And now we're taking that differentiated, high value, high performance architecture, and we are layering it with Ethernet and Ultra Ethernet protocols. So we're giving customers the best of both worlds. You have the opportunity to take advantage, again, of these types of features, but you get to serve them in a industry compatible way. So you can use our SuperNIC with someone else's switch, as long as it's an Ethernet-based switch. So you have that ability for industry interoperability. This is great for customers that want supply chain resilience. So they may choose to use our network from an end-to-end perspective for the absolute highest levels of performance, but they know that they have other alternatives and can continue to work within partnerships. So our group of engineers, both hardware and software, and team has put together both the switch ASIC, the SuperNIC ASIC, the system, and all the way up to the full director class switch system that is designed to offer the highest levels of consolidation and economic efficiency and price performance to get you to that, again, highest performance per watt per dollar that you can deliver within the AI system. On top of all of this, move towards these industry standard interoperability and using the Ethernet protocols and wires, we are also incredibly driven by open. So we are the team that developed the Open Fabrics Alliance software stack. Some of you may have some familiarity with that, as it has been adopted by the Ultra Ethernet Consortium as the software stack for UEC. We're large maintainers of it and have donated that capability into the consortia. It's used around the industry, but it gives a wonderful open base, again, for the software developer to work on. And what it means is that you user aren't going to need to do a bunch of application work in order to utilize the network. And then again, working across the industry with all of the compute players is very important to us, making sure that we have support for CUDA, for ROCm, and that both your CPU and your GPU led capabilities have full support through the product portfolio. So the goal is that whatever you are using to drive your compute infrastructure forward is fully supported by the network that you're getting from us. So our goal, make it as easy as possible, fit into the industry standard consortia, and deliver an interoperable capability that allows you, again, to pull performance out and not leave that on the table. So what we like to call this is, we like to say, this is the network that AI has been waiting for. So we're here today to share it with all of you, to give you a little bit, just a taste, a little bit of insight into the performance that we're delivering, into the capabilities that we have, into how we're working across industry standards. And I'd like to compel you all to take an opportunity to connect with us. We're obviously here at the show. We have a booth in 806, and we're going to be around today, tomorrow, and Thursday. But also come see us online. We have a tremendous amount of information to share about those details. Again, our marketing term is not the guts, but it does work. So we would love to have the opportunity to share more and figure out how we can work with you to solve the scale challenges that we know everyone is running into and facing. Like, the time is now, and it's too important of a problem to leave for later. So we strongly believe that this is an opportunity for all of us to work together and solve this across the industry, and honestly, for the world's efficiency's sake. Our products are available from the major OEM community and resellers and distributors. And you can, reach out to any of them, and of course, reach out to us. And I just want to close with, again, that reiteration that we are excited to be here with all of you developing the next network for AI, and we look forward to partnering. Thank you very much.